Okay, how was Toronto? Cold, I bet. Awesome. So now we've got the next problem, we've got a circle, and they want us to find out the radius of this circle. And they give us some other little tidbits of information. We've got a tangent segment over here, and then we've got from the end of this tangent, a segment going straight through the circle to the center. So hopefully you realize what we're looking at. We've got a right triangle, right? And this is going to be perpendicular because it's a radius to a tangent line. So let's just consult Pythagoras once again. Let's go AB squared plus BC squared equals the hypotenuse AC squared. Now it's mostly just a matter of plugging in, at least for the next step. So AB is 12, so 12 squared. BC is x, so that's just x squared. AC is x, and then 8 more, so x plus 8. And it's the whole thing squared. Ooh, that's interesting. What do we do with that x plus 8 squared? Well, I don't know if you've officially seen this, so let me work it out over here on the side. We'll do more of this stuff later in the semester, but for right now, let me just give you a mini lesson on how to multiply out something like this. This is a binomial, 2 terms, an x and an 8, and you're squaring it, so we're squaring a binomial. But really what we're doing is we're doing x plus 8 times x plus 8. Hopefully that makes sense, because that's always what you're doing when you square something, right? 12 squared is just 12 times 12. X squared is x times x. X plus 8 squared is x plus 8 times x plus 8. Now what do we do with this? Well, you notice each binomial in the parentheses here, we've got 2 terms, an x and an 8, and then an x and an 8. So we're going to multiply everything in here by everything over here. So this x is going to multiply this x. And this x is going to multiply this 8. It's kind of like a distributive property. Well, but we're going to distribute twice. We'll distribute this x over here, and then this 8 will get distributed as well. This 8 multiplies that x, and this 8 multiplies that 8. So let's do all of that multiplication. So x times the x, that'll give us x squared. X times x is x squared. And then x times 8, let's add that, is going to give us 8x. Ooh, I'm running out of room. Maybe I think I know what I'll do. And then now we move on to this 8. This 8 times x gives us 8x. And then this 8 times the 8 will give us 64. So now what do we do? Well, we've got, you notice in the middle here, we've got an 8x and another 8x. Well, those are like terms, like terms. So you combine them, right? That's what you do with like terms, you combine them. 8 plus 8, 8x plus 8x is 16x. So that's what we get from adding those two, plus 64. So that's our result there from squaring x plus 8. So let's bring stuff down. 12 squared is 144. X squared is just x squared. Equals all of this business over here. X squared plus 16x plus 64. Okay? Again, we're going to do more of this type of stuff over here later in the semester, so don't freak out too much right now. But you might be freaking out because you're wondering, what? How do we, x squared, how do we solve? Well, here we go. Don't worry. Especially in this problem particularly, you don't have to worry, because if we subtract x squared from both sides, ooh, bye-bye, x squared. And let's bring stuff down. No more x squared, so that's gone. I'm going to just ignore that now. So it's 144 on that side equals 16x plus 64 on that side, and then we just solve. Let's subtract our 64 from both sides. And what do we get? 144 minus 64. is 80. And let's bring down the 16x. I like doing that. I just like having the x term on the left. So, and there's no problem with switching stuff on either side of the equal sign. And then we divide both sides by 16. And you got x equals 5. Boom, that's what we were looking for. Okay, we've got a little bit more to go, so let's just go to it. Now we're being asked on problem 4, the next page, is ML a tangent? Is it tangent to circle N at L? Explain. So let's see. Here we've got ML. We've drawn a radius to L from the center N, and then we've got the length over here. So, and we're given all this information. So we're asking ourselves a few questions. I guess, remember, if ML is tangent, what's the relationship between this tangent, potentially tangent line, and the radius? Well, we have to have a right angle here, based on that theorem we talked about earlier. So is that a right angle? I guess, so that's kind of the question we want to know. Is ML perpendicular to NL? If you think you have an idea, just keep going and try to pause it and try to work it out. But well, this question is really, it's a triangle. So really the question is triangle MLN, is it a right triangle? Right? And going back to Pythagoras, really where we want to know, since we've got all the side lengths, does the Pythagorean theorem hold up here? Is 7 squared plus 24 squared equal to 25 squared? Is that true? Well, let's check it out. 7 squared is 49. 24 squared is 576. 25 squared is 625. Is that still equal? Well, hey, guess what? Add these two up and you get 625. Oops. That's funny. I wrote 4 for some reason. Hilarious. Yes, it checks out. 625 is equal to 625. So let's get they asked us to explain. So let's explain, shall we? And really what we're using, I said Pythagorean theorem, but technically we're using the converse. By converse of Pythagorean theorem, hope you don't mind my abbreviations, triangle MLN is a right triangle, and thus ML is perpendicular to NL. So ML is tangent. It's tangent to circle N at L. Cool. That's a nice explanation. All right, let's jump down to this theorem down here. This is another one that we talked about in class. We've got a point out here, and we've got two tangent lines, two tangent segments, really. So just to be clear, two tangent segments. That's what we've got out here. I'm going to draw this around here. So that's what these are. These are tangent segments. And as we talked about in class, if BA and BC are tangent to the circle, this is circle O, then what do we know? These tangent segments are congruent. BA is congruent to BC. Cool. So let's just indicate that here. Let's put some congruent marks in the diagram. Okay. Let's slide this up. Let's do this problem. This problem won't be too bad, because hopefully you realize there's a whole bunch of, actually one thing I wanted to say is So it says we've got a circle O is inscribed in triangle ABC. So what that means in this case is that the sides of the triangle are tangent to the circle. Okay, that's what we mean by inscribed in this case. We might also say, kind of the other way to say it is that the triangle is circumscribed about the circle, okay? Inscribed, the circle is inscribed, the triangle is circumscribed, drawn like on the outside. Remember, the circumference, circumscribed is drawn around on the outside. But here we go. So let's use this theorem down here because we've got, actually first let's just kind of emphasize our points of tangency. We're tangent here at F, tangent here at D, and tangent here at E. So this segment right here is 8 centimeters. So that means this segment over here is also going to be 8 centimeters. This is, so congruent. Sorry, I didn't draw that to look congruent, but it is. And then we've got another point out here, and then some more tangent segments that are congruent. So these are congruent. And then again, from here, from B, these are also congruent. Right, so that means this is 10. This over here is, this segment is 8. This segment is 15. Hopefully you see that this is gonna turn out really nicely. We've got AC equals just 10 plus 8. That's 18. I promise I did that in my head. Wait, no, I lied. I kind of looked at the paper at the same time. Oh, well. But AB is 10 plus 15. This one I'm doing in my head. Boom. And then BC is 15 plus 8. That's 23. Okay, and then for the perimeter, let's just add all three of those up. 18 plus 25 plus 23 is 66. So the perimeter is 66 centimeters. All right, awesome. Hopefully you enjoyed our little discussion on tangents here. And I do want to point out that on the back of this last page, this time I asked you to give a little summary, write a few sentences, at least 3. Just summarize the key concepts. I don't want you to just regurgitate the theorems, but I want you to put some of this stuff in your own words and tell me about your trip to Toronto. No, I don't want to hear about your trip to Toronto, but just tell me about what you learned and put it in your own words, please. Okay, I'll see you soon.